Okay, 17 and 18 utilize the symbol is an element of, which is this one. That is an element of, or the one with a line through it is not an element of. And so when I look at my choices here, it says fill in the blank with either of those symbols to make the statement true. Is 9 an element of this or is it not? I'm looking for this number. I see it right there. So yes, it is an element. It is in the set. So there you go. On 18, it says the number 8, is that an element or not an element of x such that x is a rational number? Okay. Rational. What the heck is a rational number? Well, a rational number is any number that you can write in the form of a over b. If you can make it look like a fraction, it's what they call rational. Believe it or not, every whole number, and we're dealing with the number 8 here, 8 can be written as 8 over 1. That's a fraction. That makes it rational. So 8 is an element of the set of rational numbers. Just to further your information about rational numbers, terminating decimals like 0.25, it terminates right here. Every number in a decimal has a place value. And when I say 0.25, what I'm really saying is 25 100ths. And then you could reduce that, but boom, I've already changed it to a fraction. So terminating decimals are also rational numbers. And then also, believe it or not, repeating decimals like 0.3 with a bar on it. Remember that really means 0.3333333 blah blah blah. If I had said 0.3 and it terminated, that would be 3 over 10. But when you say 0.3 repeating, that is actually 3 over 9. So if somebody says 0.7 repeating, that is 7 over 9. If you don't believe me, grab a calculator, take 3 divided by 9, and it'll convert it to 0.3333333. Take 7 divided by 9, it'll convert it to 0.7777777. So repeating decimals can be converted back into fractions. So repeating decimals are also rational numbers. The only numbers that are not rational are dudes like pi, 3.14159, and it goes on and on and on and on, and there's no pattern to it whatsoever. Pi, 3.14, remember pi? It's this symbol here. Probably met him in geometry class when you were working with circles. He is the only irrational, not the only, but he is one of the few irrational numbers out there. Other irrational numbers are like the square root of 2, the square root of 5, the square root of 6. Any square root that is not a perfect square. Like if I said the square root of 25, that's not irrational because the square root of 25 actually equals 5, and 5 is 5 over 1. The number that's underneath here has to be something that's not a perfect square, and then you get something that's irrational. Anyway, the answer to number 18 is 8 is an element of the set of x such that x is a rational number. And now you probably learned more about rational numbers than you cared. Okay, so now we get to cardinal numbers. Find the cardinal number of A. Set A has the numbers 110, 111, 112, 113, and the ... means continue on in that pattern until you get to 130. So that's 114, 115, 116, 117, 118, right? You can keep counting them. When you're done, you will get a cardinal number of 21. Now most people are like, isn't it just 20? A lot of people want to take They want to take the 130 at this end and the 110 at that end and subtract them and say, well, that's just 20. It's not, because when you took 130 minus 110, you eliminated this actual number of 110. What you'd have to do is say, take 130 and subtract the first 109 numbers that are before 110. And that's where you get 21. Or you can sit here with your fingers and count 110, 111, 112, 113, 114, 115. You know, count them to 130. There's 21 of them. So it's 21. That's the easiest way to work that one. And 29, ooh, a pretty graph. The graph to the right shows the number of site visitors for 7 internet-based companies. Use the listing method to list the set of companies L that have a number of visitors less than 70 million. Okay, I need a color that's not up there. Let's see, how about purple? There we go. All right, we are looking for, we want to list the set of companies L that have a number of visitors of less than 70 million. And this is a nice chart because at the top of each bar, they tell you how many millions, because over here it says site visitors in millions. So 35 is less than 70, 60 is less than 70, not 74, not 113, not 69 is less than 70. So my answers are A, B, and G. So in this box, you'll type A, comma, B, comma, G. And that brings me to my last problem, which says, determine whether the statement is true or false. Okay. It's another element. They want to know, is for an element of the set of X, right? Here's our set. The set of X such that X is an element of the natural numbers and X is even. So the number 4 has to be both the yellow stuff and the blue stuff to be in this set. So the yellow stuff just says X has to be an element of natural numbers. 4 is definitely a natural number. It's one of our counting numbers. 1, 2, 3, 4, blah, blah, blah. And X is even. 4 is an even number. So this answer here is true. Now, had they put the number 3 right there, let's say instead of a 4 they had put a 3, then that would have been false. Because even though it did this part, the word and means it has to be both the yellow and the blue, and it wouldn't be that. So then that would be a false answer. And that's the end of my examples. So what you need to do now, hopefully I've explained well enough for you to get into my math lab and work on section 2.1 and get all those questions complete. So good luck. If you have any questions, shoot me a Canvas message, or if you've signed up for the Remind messaging, that's a way you can text me so that you and we can text back and forth without you knowing my phone number and without me knowing yours. And it is totally free, and it is a very nice app for teachers and students.